In this video, I am going to show you how to evaluate inverse trig functions. Now, in the past, we have answered questions like this. Consider the unit circle. I could ask you, what is the sine of pi over 4? Okay, and so here's pi over 4 right here. And we learned that the sine of pi over 4 is 1 over radical 2, or some people like to say radical 2 over 2. Now the inverse sine, or arcsine, we are reversing these two things. So the angle is going to go here, and the value of the function is going to go here. Okay, so when you're doing an inverse trig function, which can either be written with a little -1 here, or so that's inverse sine, or sometimes you'll see it written as arcsine. These two things mean exactly the same thing. Either way, what they are asking you is, what is the angle that will give you this answer? What angle will give you this answer? So an inverse trig function is an angle. It's the angle that it would take to give you the answer inside. And so as we just saw on the previous setup, we know that the angle that has this sign is pi over 4. So the answer would be pi over 4. Same thing right here. Okay, now there's just one extra little thing we have to watch out for. There's actually more than one answer. If we were just to leave it as this concept of what angle would give us this answer, all right, the sine of what angle is 1 over radical 2. There are two angles that would have that answer. This angle right here is the one we just talked about. But this angle over here has the same reference angle, all right, and it's also positive. So this is the angle 1, 2, 3 pi over 4. So why not 3 pi over 4? All right, 3 pi over 4 could also be an answer to this question. But that's a problem because this would not be a function then. The inverse trig functions would not be functions if they had more than one answer. So what you have to do is, a long time ago they decided on some restrictions. And for the sine function, the restrictions go like this. For the sine function, hold on. For the sine function, the inverse trig function is only defined from here to here on the unit circle. All right, now when you think about it, that allows us to capture the positive values and the negative values. Okay, so inverse sine is only defined between pi over 2 and negative pi over 2. Okay, nothing else. For that reason, the answer to this question is only pi over 4 and not 3 pi over 4. All right, so overall we have these restrictions on the other inverse trig functions. So cosine, inverse cosine or arccosine is only defined basically for the top half of the unit circle. And you know what, let's go ahead and write this in here. So for sine, it was defined for the right side of the unit circle, but hopefully you can see that that goes from negative pi over 2 to positive pi over 2 at the top. Now looking at the cosine function, if we say that the inverse cosine function is only defined for the top half of the unit circle, that's from 0 to pi. 0 to pi. Notice in both of these cases, by making the inverse sine defined for the right side of the unit circle, we're capturing the negative and the positive values for sine. Think about the way that the y values are positive high and negative low. That'll help you remember that it's this side of the unit circle. If you made a mistake and you looked at the top half of the unit circle, it would be all positive up there. For cosine, again, by choosing this interval from 0 to pi, we're getting the positive values and the negative values. And then for tangent, by doing, we're back to the right-hand side of the unit circle. And again, tangent is positive in the first quadrant, negative in the fourth quadrant. So this is, again, allowing us to get all of the values, the positives and the negatives. There's one little twist here. Notice that I've put open circles at these endpoints. So this is still negative pi over 2 to positive pi over 2. But think about it. The tangent is y over x, right? It's sine over cosine. So tangent is not defined at these values because, for example, this is the point 0, 1. The tangent up here would be 1 over 0. That would be undefined. So that's why I'm leaving these points out, because they would be undefined. So I will show that here when I mention the restrictions by using parentheses instead of brackets. So inverse tangent or arctangent is only defined from negative pi over 2 to positive pi over 2, but not including those endpoints. All right, let's jump in and do some problems. The inverse sine of 0. The inverse sine of something is an angle. It's the angle that would give you 0 for an answer. So we're looking for an angle. In other words, you should be asking yourself this. The sine of what angle will equal 0? Now, in general, there would be two answers to this question. If you look at your basic unit circle, all right, remembering that sine is the y value, it could equal, the sine can equal 0 in two places. All right, because this is 1, 0, the y value is the sine, so the sine is 0, and this is negative 1, 0, the y value is the sine. That's why we had to put those restrictions on, because you can't have a function that gives you more than one answer output for a single input. In this case, angle 0 and angle pi. Only one of these is in the domain of the function. So inverse sine is only defined on the following interval. Negative pi over 2 to positive pi over 2. Doesn't operate anywhere else. So therefore the only one of these two angles that will work is this one, which happens to be 0. So the answer to the question is in fact 0. Okay, because we're saying that the sine of angle 0 is 0. Anyway, I think it'll make more sense when we look at some other problems. So the arcsine of radical 3 over 2. Again, the arcsine, the inverse sine, is an angle. We're looking for the angle that will give us this for an answer. In other words, you should be thinking, okay, the sine of what angle is equal to radical 3 over 2? This is a question you should be asking yourself. Well, based on the things that we have memorized, a reference angle should be popping into your head, and that is pi over 3. Okay? We know that the sine of pi over 3 is radical 3 over 2. That's one of the things that we memorized. All right. So pi over 3. Pi over 3 is right here, and that is within the area that is defined for sine. All right, because sine is defined from negative pi over 2 to positive pi over 2. That includes pi over 3. So the answer is pi over 3. One more time, notice that without the restriction of saying sine, inverse sine is only defined from negative pi over 2 to positive pi over 2. Without that restriction, there would have been two answers to this question, because the sine of pi over 3 is radical 3 over 2, but this point also has a reference angle of pi over 3. And so it would also have a sine of radical 3 over 2. And it would even be positive radical 3 over 2, because sine is positive in both of these positions, as opposed to down here would be negative radical 3 over 2. So only the restriction that we placed on it narrowed it down to this choice instead of this other one that we normally would have. Alright, I'm not going to re-explain that every time, but I thought I'd just say that one more time. Okay, when you look at this, the arcsine of radical 2 over 2, you should be thinking, what angle has a sine of radical 2 over 2? And the first thing that should be popping into your head is pi over 4, because the sine of pi over 4 is radical 2 over 2. And pi over 4 is within the realm where inverse sine is defined. Right? Pi over 4 is right here. And sine is defined on the right hand side of this circle. So we're good. Look at number 4. The inverse sine of 1/2. You should be thinking, okay, what angle has a sine of 1/2? Alright, the sine of what angle is equal to 1/2? Based on what we've memorized, the first thing that should be popping into your head is pi over 6. Alright, and pi over 6 does fall within the defined area for inverse sine. Alright, let's keep going. Alright, inverse sine of negative radical 2 over 2. You're asking yourself, what angle has a sine of negative radical 2 over 2? And keeping in mind that inverse sine is only defined from here to here, negative pi over 2 to positive pi over 2. This is the only place where it's defined. Now again, when you see the radical 2 over 2 and you're talking about sine, the first thing you should be thinking is, alright, we're definitely dealing with a reference angle of pi over 4. Okay, so if you were to picture a unit circle, okay, and here are some pi over 4s happening. Alright, these are the 4 places that have a reference angle of pi over 4. Only these two are in the part of the domain of the inverse sine. Alright, inverse sine is only defined for these two. So we can already say no on these two. So it's either this one or this one. But only one of them is negative. Only one of them has a negative sign. And it's this one down here. So this is another no. That just leaves us with this one. Okay, it's only these two were defined for the inverse sine function, and this is the one that's negative. So what do we call this? Because we have to stick to the right hand side of the unit circle, you cannot call this, what would this be? 1, 2, 3, 4, 5, 6, 7. You cannot call this 7 pi over 4. Instead, the only thing that you're allowed to call this is
negative pi over 4. Okay, because that way you're staying on this side of the circle. You're not going outside of that. So we have to call it negative pi over 4. Okay, I'm sort of over-explaining this because I know this is new to a lot of you. But every time I do another problem, I'm going to go a little faster. So when we say the arc cosine of 0, this is an angle. It's the angle whose cosine is 0. In other words, you should be asking yourself the cosine of what angle is equal to 0. Now if you picture the unit circle, okay, here's my unit circle. Cosine on the unit circle is an x value. So these are the two places that have an x value of 0. Okay, 0, 1, 0, negative 1. Alright, both of these angles, pi over 2 and negative pi over 2, both of these have a cosine equal to 0. However, cosine is only defined for the top half of the circle. So that tells us that the correct answer is pi over 2. Okay, number 7. Inverse cosine is an angle. It's the angle whose cosine is radical 2 over 2. Right away you should be thinking pi over 4. Alright, the cosine of pi over 4 is radical 2 over 2, which is the same thing as 1 over radical 2. And that is within the zone that's defined for cosine. So that's it. Okay, again, arc cosine of negative 1. This is an angle. It's the angle whose cosine is negative 1. Okay, so what angle has a cosine of negative 1? Let's look at the unit circle again. Alright, cosine is an x value on the unit circle. An x value of negative 1 would be right here. That's the only place on the unit circle that has an x value of negative 1. This is negative 1, 0. That's the cosine right there, the x value. That's the only place. Is it within the defined domain for arc cosine? Yes, it is. Cosine is defined from 0 to pi. Okay, including pi. So the answer is pi. Okay, because this is the place where the cosine is negative 1. Okay, number 9. Arc cosine of radical 3 over 2. Arc cosine is an angle. It's the angle whose cosine is radical 3 over 2. We've memorized that that is pi over 6. Cosine of pi over 6 is radical 3 over 2. Also, pi over 6 is within the range that is defined for inverse cosine. Alright, it's in the top half of the circle, so it's okay. Alright, moving on to number 10. Inverse cosine of 1/2. This is an angle. It's the angle whose cosine is 1/2. That is pi over 3. Is pi over 3 within the restricted domain for cosine? Yes, it is. Pi over 3 is right here, and it is within the restricted domain for cosine. So that's the answer. Number 11. Arctangent of 1. Arctangent of 1 is an angle. It's the angle whose tangent is 1. The first thing that pops into my head is pi over 4. I know the tangent of pi over 4 is 1. So we have memorized that. Remember the chart that we memorized? Tangent of pi over 4 is 1. We memorized that. Okay, the question is pi over 4 within the restricted domain for tangent? Let's see. The restricted domain for tangent is the right hand side of the circle, from negative pi over 2 to positive pi over 2, non-inclusive of those endpoints. And pi over 4 is right here within the restricted domain, so it's fine. Number 12, arctangent of negative radical 3. The negatives. This is where things get interesting. Everybody look sharp. Arctangent is an angle. It's the angle whose tangent is negative radical 3. So ignore the negative sign for a minute. What's the angle whose tangent is regular radical 3? Alright, that should be one of the things that's on our chart. We're talking about pi over 3. That means pi over 3 is definitely the reference angle. So it's just a matter of what's the actual angle. But it's going to have something to do with pi over 3. Alright, because the tangent of pi over 3 is regular radical 3. Okay, now, since the reference angle is pi over 3, I'm going to draw pi over 3's, a circle of pi over 3's. Okay, all four of these angles have a reference angle of pi over 3. That means the tangent of any one of them is going to give me some kind of radical 3. Now, tangent is positive in the first quadrant and in the third quadrant, and tangent is negative in the second quadrant and the fourth quadrant. Okay? However, when we're dealing with inverse tangent or arctangent, we're dealing with a domain restriction that keeps us on the right hand side of the circle. Okay? So that means that only these two are possible. The other two are not within the restricted domain. Now this time we want a negative radical 3, not a positive radical 3. That's why we need to pick this answer. Okay, we need to pick this angle right here. And we have to call it negative pi over 3. We have to look at it that way. We cannot call it 5 pi over 3, because that takes us into the undefined zone over here. If we just go dink straight from 0 to negative pi over 3, then we stay within the defined zone. So the answer is negative pi over 3. Alright, number 13. Inverse tangent of radical 3 over 3. Don't forget that radical 3 over 3 is the same thing as 1 over radical 3. So, this is an angle. It's the angle whose tangent is 1 over radical 3. Remember the chart? Pi over 6. Now, that means pi over 6 is definitely the reference angle. Alright, we know that the tangent of pi over 6 is 1 over radical 3. So, in this case, pi over 6 is going to turn out to be the answer because we want it to be positive, and pi over 6 is definitely within the defined restricted domain. So we're good. Alright, and last one. The inverse tangent of 0. One more time. An inverse tangent is an angle. What angle is it? It's the angle whose tangent is 0. Okay, so the tangent of what angle is 0? Now this is not on the chart. There are no 0 answers on here. We must be talking about a quadrantal angle. So let's go ahead and just do a quick sketch of our little unit circle. Okay, and remember, the quadrantal angles go like this. This is 1, 0. This is 0, 1. This is negative 1, 0. And this is 0, negative 1. Now tangent is y over x, sine over cosine. So which of these are going to give me 0 for an answer? Well, this y over x, 0 over 1, this is going to give me 0. Alright, so an angle of 0 gives me 0. And what else? This would be 1 over 0, that would be undefined. 0 over negative 1, that's also 0. Negative 1 over 0, that's undefined. Alright, so these two angles, 0 and pi. Okay, this is 0, this is pi. Both of these angles have a tangent of 0. But the domain restriction will make the call for us which one it's going to be. And the domain restriction says that tangent is only going to be defined on the right hand side of the circle, from negative pi over 2 to positive pi over 2. So with that in mind, if we're going to stay on the right hand side of the circle, that means ding ding ding, this one has to be the answer. So the answer is 0. Alright, the tangent of angle 0 gives you a value of 0. Okay, and that is going to do it for this video. We will practice more on the next video. I will see you then. Thank you and good night.